Hey there, everybody. Welcome back. This is Math 21, Introduction to Statistics at College of the Sequoias. Might be a different number at your school if you don't attend College of the Sequoias, but this is an introductory stats class. And we are still looking at summary statistics and things like that. This section we're working on 3.4. 3.4 is on measures of position and outliers. And it's going to lead us to something called the z-score. All right. So to illustrate this, we're going to have a bell curve. So this is a bell curve, and in the center we have our mean. So that's our mean. And remember in 3.2 we talked about standard deviation or deviation. If we go right one deviation, this is mu plus 1 sigma. If I go left one deviation, I've got mu minus 1 sigma. And if I look at this, on a standard bell curve, the way these standard deviations line up is that this leads to 34% of the data is in this region, and this has 34% as well. So within one deviation, we have 68%. And if I go out another deviation, mu minus 2 sigma or mu plus 2 sigma, well, each one of these regions is another 13.5% approximately. Which makes this approximately 95%. And if I go out a third deviation, mu minus 3 sigma or mu plus 3 sigma, these little regions each have 2.35% of the data in it. And that makes this region right here, within 3 deviations, or within 3 sigma, is 99.7% of the data. And the green one was within 2 deviations. And 2 sigma, and the middle set was within 1 sigma. And there is still stuff on the outside. On each side, this is 0.15%. So there is stuff outside of 3 deviations, but it's not a lot. And what if I have, so this is called the empirical rule. So make a note of this. In fact, you're going to use this a lot, so you should memorize these. Okay? Memorize values. It'll save you time and effort and make you, well, you may not like it right now, but it'll make you happier in the long run. All right, so let me give you some examples where we use this. So I was looking up some stuff, and I'm going to draw two bell curves. This is on height, and top one will be on males. Sorry, this is going to be a two gender system for this. They don't have a lot of data on people that are not in that system. And this will be on females. And this is going to lead to the idea of our topic. For men, the mean height is 70 inches. So we're looking at height. Height in inches. And for us, for guys, sigma is 4 inches. So if I go one deviation to the right, you got to make that tail long in the front. Mu plus sigma is 74 inches. If I go to the left one, it's -4 is 66 inches. Do it again. Mu minus 2 sigma is 62 inches. And Professor Jones clocks in at 65.5. This is Jones. And I'm real proud of my half inch. 65.5 inches tall. Okay. And I had a student last semester. Name is Brooke. We'll look at women. The average height for women, this is in the United States, is 65 inches. And sigma is 3.5 inches. Now, if I go up 3.5 inches, I've got 68.5. And if I go up another 3.5, I'm at 72. If I go down, 65 minus 3.5 is 61.5. And if I go down again, we're at 58 inches. And Brooke was 4'11". 4 foot 11 inches, which means she's in this region right here with 59 inches. Now, this is mu minus 2 sigma. And this is mu minus 1 sigma. We're both in that region. So both Jones and Brooke are in the mu minus 2 sigma to mu minus 1 sigma region. Now we can look at our height, 65.5 inches, 5'5.5" for me. And Brooke was 4'11". I am taller than her. But relative to other guys, am I taller than her with respect to guys than she is with respect to girls? So this is the logic of what we're going to do here. Since guys and gals have different mean heights, it's not really proper to compare them directly. So this is what we do. This is like this is like an apples and oranges thing. Apples and oranges thing. They're different fruit. So what we do is we convert our values to something called a z-score. The z-score. And in words, the z-score is the multiplier on sigma. You've got mu plus 1 sigma, mu plus 2 sigma, mu plus 3 sigma. We'll go the other way, mu minus 1 sigma, mu minus 2 sigma, mu minus 3 sigma. And I've got some value in here. This was Jones, and on my score is X. X equals my height. So what this is doing is, okay, well, what is my z-score? It's related to this mu. It goes like this, mu plus z sigma. I'm trying to figure out what is this value. And if we have z-scores, the logic is this. The further the z-score is from 0, the less you are like the average. Okay? So that is really where it comes from. So my X score is it, so here, right here, that would be z equals -1. And if I were right here, z would equal -2. But what's mine? I'm between -2 and -1. So that we calculate it to figure out where we are. So let me illustrate doing that. I'm going to take this equation and we're going to manipulate it. X equals mu plus z sigma. I'm going to subtract mu from both sides. This is some algebra. And if I do, I have x minus mu equals z times sigma. And if I want to get z by itself, I'm going to divide both sides by sigma. And what I end up with, the sigmas cancel there, and I get z equals x minus mu over sigma. That is the formula for a z-score. Z-score formula. Where mu is the mean. Sigma is our deviation. And it was that ugly formula, but StatCrunch will give it to us. Or maybe gotten for you already, like where I gave you the guys and girls heights and deviations. It was already calculated by people. And X is the individual in the population. So let's calculate David and Brooke's score. David versus Brooke. Okay. So for me, my z-score, my height, I had x equaled 65.5. That was my height. And Brooke had x equaled 59. And what were the values for these? For guys, mu was 70 and sigma was 4. And for girls, mu was 65 and sigma was 3.5. So what I'm going to do is I'm going to take the values I know and put them in. In each case, it's x minus mu over sigma. X is 65.5 for me, minus mu, which is 70, and divided by 4. If I do the same thing for Brooke, x minus mu over sigma, she's got 59 inches. Her average height is 65, and their deviation is 3.5. So I got to pull out a calculator. If you don't use parentheses, you should hit the equal sign first. So right now I'm doing 65.5 minus 70. I'm going to hit equal. Negative 4.5, and then I'm going to divide by 4. My z-score was negative 1.125. An option for doing this all at once, if your calculator has parentheses, is do the top in parentheses. Okay? So I'll illustrate that on Brooke's side. I've got parentheses here too. I'm going to do parentheses 59 minus 65, end parentheses, and then divided by 3.5. And I get z equals negative 1.71 to 2 decimal places. The reason why I say use parentheses, look what happens if I don't. If I just say 59 minus 65 divided by 3.5, I got 40.42, 43 if I round. If you don't use the parentheses, it's only going to divide the 65 by 3.5, not the 59. So use parentheses or calculate the top separately, okay? And I did 3 decimal places on the other one. I might as well do 3 decimal places on hers, negative 1.714. So let's draw what that means on a picture. So I'm at 1.125 negative, which is just a little bit past this one. There's David. And Brooke was at negative 1.7, which is closer to negative 2. There's Brooke. Now, by converting to a z-score, we can both be compared against each other. To one another. So my score was only negative 1.125. Hers was negative 1.714. With respect to our genders, I am taller than a larger percent of men, then Brooke is taller than a percent of women. And if you kind of like show it, I'll show it on 2 different graphs real quick. Try to. So I'm closer to the 1, she's closer to the 2. If I like draw a solid line and I fill in this area over here, and I draw a solid line going up and I fill in this area over here, the area underneath the graph, area under graph is bigger for me. Which means if there were 100 people, 100 guys and 100 girls, and we were comparing, I'm going to be taller than more guys out of the 100 than Brooke is taller than girls out of the 100 on average. Okay, that's the idea of z-scores. So like the z-score is like how far left or right are you from the center of your graph or your thing. The z-score is how far left or right from the center or mean. From the center of a bell curve, or the mean is usually the mean. And again, this allows comparisons between groups with different means. Now, I was quite happy. If we had done this class live, I guarantee whatever girl I asked to give me their height, they were going to be taller than me. Because being under one, being below -1 means I'm like shorter than like 70% of guys. That's just how it is. Let's see. Is it 70%? Well, yeah, it's under 84%. The reason why is, okay, so this is our graph of our bell curve. To the right is 50%, and to the left is 50%. So I have all of this 50% on mine, then 34%, then another sliver. So let me show you that on mine. So that was 70, and David was over here between -2 sigma and -1 sigma. So this region over here is 50% right off the bat. One standard deviation added another 34%. So that part, 50 plus 34, is 84%. So David is shorter than over 84% of guys. God, that's depressing. I never really stopped and looked at it like that. Because I'm over here, there's another sliver right there that adds a little bit more. It's not much more, but it might make it 87 or 88. Yeah, depressing. I don't know why. I don't know why I place a big thing on height. Maybe it's because all my friends are taller than me and they like to point it out whenever we're out in public together. Uh, they make jokes about like, or if we're over playing like Dungeons and Dragons and something is in the upper cupboard, they say, "Why don't you go get it, David?" "Oh, wait, no, you need a step stool," stuff like that. My brother's the worst. My brother's close to 6 feet, so when I stand next to him, the top of my head comes up to like right here, and he has to look down to look me in the eyes, and he smirks every time he does it. He's my younger brother. He's less than a year younger than me, and I think he gets a big kick out of being taller, even if it's on a subliminal level. So I'm aware of height. I'm conscious of it. So let's talk a little bit more about z-scores. Any z-score that is greater than 2 or -2 is, oops, or z is less than -2, which means, I'll show you on the picture. We got mu plus 1 sigma, mu plus 2 sigma, mu minus 1 sigma, mu minus 2 sigma. If a z-score is, the z-score is out here, is outside these middle two, outside this middle region, right here. And recall, I said within 2 deviations was 95%. The z-score is out here, or puts us out here. The value is considered an outlier. Okay? The value is considered an outlier. Thankfully, I'm not an outlier. There's that. So being an outlier means you're in the outside 5%. We'll hit on more of that later. So let's get back to talking about central tendency again. Recall for bell-shaped, our ideal measurements are the mean, mu, and deviation, sigma. On skewed graphs, we didn't like the mean. For skewed graphs, we don't like the mean. Median was better to locate the center. And so just like on bell-shaped, we had 2 things. The mean just gave us where the center was, and the deviation showed us our spread. So we need average and spread. Median is our average here, just like it is there. And for spread or dispersion, on the bell-shaped, we did deviation. For skewed graphs, we use something called the IQR. IQR for spread. And what IQR stands for is interquartile range. All right. And this is how you find it. So if we have we put our values on a line, remember the median's in the dead middle. The lowest one, the one up all the way to the left, is our minimum value. And over here on the right would be our maximum value. In the middle, we got the median value. If we go halfway in between, this is like if we're going to the left, this is the 50% mark. So halfway would be the 25% mark. And going all the way up would be 100%. This is like the 75% mark right here. So it's like the median of the median, the middle of the middles. It's kind of like a mid-median. Mid-median. That's a David word. This one here is called Q1. This is Q3. Q1 is quartile 1. And it represents where 25% of the values are lower. Values are lower than this value. Okay. And this is just like money. Q1 is like 1/4. Q3, how much money is 3/4? Well, Q3, 3/4 is 75 cents. Quartile 3, 75% of the values in the data set are less than Q3. This effectively makes like the median is effectively Q2 or 50% mark. And you could call the max value Q4, but we just tend to call it max. Which means 100% of the values are less than it. I guess I should say less than or equal to it. Okay. So IQR, what is it? The IQR, to calculate IQR, you have to basically sort the data, find Q3 and Q1, and IQR equals Q3 minus Q1. Okay. It can be a pain in the butt, especially with the large data set. Finding the media is a pain already. Then finding the quartile marks is another pain. Thankfully, we are blessed with StatCrunch. StatCrunch version. Yep, you know it. It's where we've gone this whole time. Stats, summary stats, column. and it's on the list. Pick the column, pick IQR. Okay. Now, I'm gonna just sketch a little line again. Q1, Q3. So the IQR is Q3 minus Q1. It's the distance between these two. On a number line. It's that distance right there. And I just drew a line above Q1 to Q3. Notice outside of it is kind of ignored or neglected. Slash neglected. In terms of the IQR, that's where outliers are. This is where the outliers are. Outliers, if they exist, are going to be on the edges. So remember that term we use, resistant? If a summary statistic is resistant to outliers, they have little impact. If we're talking about income here and we're finding out the interquartile range of a class, Bill Gates in the room, he's one person. He's not going to be in the middle 50%. He's going to be way on the edges. So it kind of ignores the input of Bill Gates, like on income, which means IQR is resistant. IQR or interquartile range is resistant. Is resistant to outliers. And if I were to do it a little bit even further, where we consider outliers are not just on the left and right of it. So let's do that again. Here's my median. Here's Q1 and here's Q3. We don't just say it's to the left of Q1 and anything to the right of Q3 is an outlier, because that's covering 50% of the stuff. What we do is we make these imaginary fences. And so we're going to make a fence like over here and a fence over there. Outside these fences are outliers. Will be outliers. Okay. How we find these fences, I drew dotted lines, but I didn't really say what we do. This one over here on the left, which is really close to the minimum amount, that's our lower fence. It's called the lower fence. And the one on the right is called the upper fence. It's kind of like if the center was the house, the interquartile range is the house. Outside the interquartile range, but in between the fences is kind of like the yard. And the outliers are in the street. And how do we find these fences? We can calculate them. The lower fence has a value that is equal to Q1 minus 1.5 times the IQR, interquartile range. The upper fence is Q3 plus 1.5 times IQR. Okay. So let's take a look in StatCrunch. I want to show you how it's working. I'm going to sign into Pearson. And I think I'll maximize this to make it a little bit better right now, make it easier to see. I've got 3 stats classes, doesn't matter which one I pick. They all have the same coursework and same design. StatCrunch is here on the left. I'm going to select it. I'll click visit the StatCrunch website. Note, if it does this, it says, oops, you have not accessed the page properly. To access this page, you will need to sign into StatCrunch. Just close it and reopen it. See? I know, it does that. It's like it doesn't it's like Pearson doesn't transfer your login information fast enough. And so StatCrunch goes, nope, you're not registered. It's just easier to close it and reopen it. I'm going to use my data sets that I have. And, oh, good to show you. When you click on data sets, there's all sorts of data sets out there that I did not make. They are offered. People did other surveys and stuff. I bet this superhero one's pretty good. Professor Saul, I kind of want to see that. I'll take a look at that later. I'm going to open that up for my enjoyment later. We'll look at my student survey that I did in spring of 2020. And I was mentioning heights. These are best to do on, or the bell graph was best to do on height or on bell curves. Height. Oh, I've got an outlier here. Look at that. Height 0 up to 100. Wow, 100 is broken down in increments of 50. I got someone that says they were between 500 and 550 inches tall. Now, clearly that's wrong. I'm going to go down and find them. 5'11". I'm betting this student was 5 foot tall, 11 inches. Now, when you get data and you get results like this is a good time to discuss it. You have the option of discarding it because it's clearly not true. No one is 511 inches tall. Okay? Nobody. How tall is that? 511 divided by 12 is 42.5 feet tall. That's like a 4-story building. No one is 4 stories tall. So either you can delete it, or if you think you know what they mean, like I think this person said 5'11", I could optionally replace this with 5'11" in inches. 5 feet is 60 inches, and add 11 would be 71. And I can do that. And I'm going to check to see if anyone else made any other errors before I go on. 5.9. I don't know if they meant 5.9 or 5 foot 9 inches. Since I don't know what they meant, I'm going to delete that row. 5'6". Do they mean 5.5 feet tall, or was it a little over half? The decimal's throwing me off. I'm going to delete that one. Oops. Edit, undo, delete. I deleted the wrong one. Delete that one. Any others? There's a 5.4, 5.4. All right, now I'm going to redo that histogram, take a look at it. Then we'll look at the IQR. See, it's got a bell curve. But if we look at the one for siblings, it's skewed right, isn't it? The sibling graph is skewed right, so we don't like it. We don't like using mean or standard deviation to represent that there. So let's find the IQR for siblings. So I'm going to go in, I'm going to go stats, summary stats, columns. I'm looking at siblings. This has to be data that is numerical. You cannot do IQ, you cannot find the IQR using colors, like the color of a hair or stuff like that. In fact, I'm going to do all of them. I'm going to do, we can select the minimum value, and then I can hold down Control and click Q1, and then I can click median, and I can click Q3, and I can click max, and then I'm going to show the IQR. So for siblings, this is what I just did in StatCrunch. So I did StatCrunch on siblings. For siblings, I did stats, summary stats, columns. I selected sibling column. And then I requested min, Q1, median, Q3, max, and IQR. That's what I asked for, and look, it gave it to us. StatCrunch gave me the answers. The minimum was 0. Some people didn't have any siblings, which meant they were an only child. Q1 was 2. They had 2 siblings, so there's 3 kids. The median was 3. Q3 was 5. There was a lot. That seems pretty big, doesn't it? There were several students that had above 6, between 6 or 6 siblings, which meant 7 kids. There was 8 people out of like 100. That seems large to me, but maybe it's not. And max was 10. 10 siblings meant 11 kids. The IQR is listed as 3. Does that work? Well, the IQR is Q3 minus Q1. Q3 was 5. Q1 was 2 minus 2. 5 minus 2 is 3. That's correct. If I show that like on a little number line, I make a horizontal line. The min is on the left. The max is on the right. Q1 or Q2 is the middle, the median. Q1 is there halfway between min and median. Q3 is halfway between median and max. Now, the reason why I showed all these rather than just showing you IQR is these 5 values they make up what we like to call the 5-number summary. And we'll talk more about that in 3.5. All right. So here we're just looking at the IQR. How do we calculate it? Let's calculate the fences. Let's calculate the fences here. And recall lower fence is Q1 minus 1.5 times the IQR, and upper fence is Q3 plus 1.5 times the IQR. So I'm going to jot down those values real quick. Q1 was 2, Q3 was 5, and that makes IQR 3. So let's calculate them by hand. Q1 is 2. And then I'm going to do minus 1.5 times, putting in parentheses like that makes a multiplication. IQR is 3. 1.5 times 3 is 4.5. Two minus 4.5 is negative 2.5. Okay. Upper fence, we had 5 was Q3 plus 1.5 times the IQR is 3. That's 5 plus 1.5 times 3 is 4.5 equals 9.5. I'm going to just show you the stuff with the siblings. The minimum value was 0. The maximum value was 10. The median, I got it on the screen, was 3. Q3 was 5. Q1 was 2. Maybe this isn't a good way to show it. Maybe I should put it in proper scale. Let's do this in proper scale. Okay. So I'm going to draw a number line. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I know I'm going to need some negative numbers, so I'm going to put them down. So my minimum value was here at Q1. Or at 0, sorry, not Q1. Q1 was at 2. The median here is at Q3. Our median is at 3, not Q3, at 3. Q3 is at 5. Notice it's further from the median than Q1 is. It's not an average distance. It's you count or you sort them and do them in sequence. And max was way over here at 10. So the max is a lot further from the median than the min is. Our lower fence, we just calculated, was negative 2.5. Our upper fence was right here at 9.5. Now, the minimum value was 0, which means there are no outliers. To the left. But how many students were there for 10? there was one student that had 10 siblings. But the person with 10 siblings is an outlier. That person is our Bill Gates of siblings. This is an unusual occurrence. To have 10 siblings. All right. Check this out. I just illustrated all that. Let's look, let's do a box plot. So 3.5 is on the 5-number summary and the box plot. Okay. Let's do that here. So the 5-number summary, I'm going to keep this nearby because I'm going to need the numbers. Actually, I have them on the screen, right? The 5-number summary in order is min, Q1, median, Q3, max. In order. You write them in order. You don't put them out of order. Okay. And we just did that for siblings. For siblings, this was 0, 2, 3, 5, and 10. Min, Q1, median, Q3, max. Now, how do we draw a box plot? This you can sort them by hand and do it to get to this. I recommend throwing it into some statistical software. The one that we use is StatCrunch, and finding it that way. Okay. So drawing a box plot. Box plot, or it's also called a whisker plot. Or box plot and box and whisker plot. It's called a few names. So start off, you need requirements are you need the 5-number summary. 5-number summary is a must. Must. We also need the lower and upper fences. Also needed are the fences. As a reminder, the lower fence is Q1, whatever value that is, minus 1.5 times the IQR. And the upper fence is Q3 plus 1.5 times the I just mangled that. Let's try that again. Upper fence is Q3 plus 1.5 times the IQR. Okay. All right, so that's our first part. That's what we need. Now, drawing. So that's what's needed. Now let's take a look at the steps to draw it. So drawing it. Okay, step 1, draw a number line. That includes the 5 numbers. And if you and the fences. Okay, definitely fences that are inside it. So that's step 1. Step 2, make vertical lines at the 5 number summary. Lines above it. At the 5, each of the 5 number summary values. And I actually started to do that in the last picture, or the one I just did, didn't I? Started doing that. So it's going to be similar to that. It's going to be similar to that when we do it here. And then what we're going to do is make a box connecting the top and bottom of the lines for Q1, median, and Q3. Then we're gonna mark fences with brackets. So the lower fence, we'll do a open bracket. Open bracket is where it starts. And upper fence will be closed bracket, which is the right-hand bracket. Like that. Okay. Then connect Q1 with the lowest non-outlier by a line. And if that's the median, or if that's the min, like if there's no outliers on the left, connect it with the min. Connect the min. And we'll do the same thing on the top. Connect Q3 with the largest non-outlier. Which may be the max. So it's the value closest to the fence without being outside it, both of these. These 2 values are the closest to the fences. without being outside it. And then finally, mark outliers with an asterisk or star. Okay. So let's do that for our sibling plot. Pause it if you need a second to finish writing that down. You might need to rewind it. Let's do it by hand for the siblings. And so I'm going to write down what we had. Siblings, we had 0, 2, 3, 5, 10 was our 5-number summary. The IQR is Q3 minus Q1, which is 5 minus 2, which equals 3. Lower fence is Q1 minus 1.5 of the IQR. We already did this. It was 2 minus 1.5 times 3, ended up being negative 2.5. And the upper fence was Q3 plus 1.5 times the IQR, which was 5 plus 1.5 times 3 was 9.5. All right, so let's do our summary. I'm going to draw a number line. My maximum value was a 10. My minimum value was a 0. And then, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's close to being a good number line. 0 to 10. I'm going to draw, so I've got a number line that includes those values. If I want, I can include the one with the lower fence over here. If the fence is outside the thing, you generally don't need it, but I'm illustrating where it is. We will draw a vertical line at the min, Q1, which was at 2. The median was Q3. 5 was Q3. Sorry, median is 3, not Q. I keep saying Q3 there. The median is 3. 5 is Q3. And the max was 10. So I drew my 5 vertical lines above my values on the number line. And then I make a box connecting the top of the lines for Q1, median, and Q3. Like that. Okay. I'll mark the brackets or fences with brackets. I'll use green for this. One of them's over here and we don't really need it. And 9.5 is right about here. And then, okay, so I'm going to look and see, did we have a 9 on here? we did have a 9. So the lowest value, let's start with the other way. Okay, so I marked the fences. Next, I connect Q1 with the lowest non-outlier. The fences here, the lowest value, the value closest to it was 0, the minimum. So I'm going to make a vertical or a horizontal line connecting that right there. Nine was the lowest value or the value closest to Q or the upper fence without going over it. So right there. I'll put a point there. I'm going to connect a line there like that. And then the max value 10 was an IQ or as an outlier. So I'm making it an asterisk or star. Now this, we can do this in StatCrunch as well. Often people don't do vertical lines for the min and max. It makes the outliers easier to see. So if I redid that on the number line that we had, I had a fence at 9.5. I had the min was 0, the max was 10. I'll put points there. Q1 was at 2. The median was Q3, or median was 3. Q3 was 5. And they'll go like this. Connect that line like that. The lowest value inside the upper fence was 9. We'll connect a value there. And they make the asterisk like that. Makes it a little easier to identify the outlier. Okay. How can we do this in StatCrunch? Notice I didn't show the fence here that was on the left. Fences that are outside min and max don't need to be shown. Outside the min or max don't need to be shown. So I didn't do the one on the left. All right, in StatCrunch. You're going to do graph, Boxplot. And then you need to select the column with data. And I believe you need to mark it, draw horizontally, but let's take a look. They might have changed StatCrunch. Let's check. Stats, I'm sorry, graphs. Graphs, Boxplot. I'm going to do siblings here. Use fences to identify outliers is automatically checked. Check mark the draw boxes horizontally. So I'm going to click that. And we'll click compute. And doesn't theirs look like mine? They don't show the upper fence. When you do it by hand, you put the upper fence down there just so you can see it, really. Know where it is. They didn't do it. They have an asterisk where it is, where the star is. Notice, and theirs, they have everything perfectly evenly spaced. But you can see it on my box plot as well. So notice, the right whisker, that's what it's called. These are the whiskers on the left and right. Whisker and whisker. Note the right whisker is much longer than the left one. This graph is skewed right. Oop, I'm off that camera there. The right side of the box is also bigger. Is larger than the left side. Which is also a strong indicator of skewed right. Of skewness. And in this case, to the right. So if one whisker is longer than the other, long whiskers indicate skewed graphs. Or I should say uneven whiskers. Show skewed graphs. And that is literally 3.4, 3.5, all in one nice little tidy package. You're doing IQR, you're doing the fences, you're doing the 5-number summary, and you're doing box plots. I will relist the commands here right at the end, and maybe we'll do the formulas on one last page at the end. So it's the last thing in your notes if you've been taking notes. In StatCrunch, we can do stats, summary stats, columns, to find min, Q1, median, Q3, max, and if you're so inclined, IQR, but subtracting Q3 and Q1 is really not that hard. You also do stats, or not stats, graph, box plot, select column, and mark horizontal plot. Does StatCrunch show us the whiskers? I don't think it does. Or that does it show that lower fences? Let's take a look at it. Is there anything in here that gives lower fences? I'm going to check. This is, if I don't know something, I'm going to look it up. So this is my statistics box. Got N, which is sample size, mean, variance. That's not it. We've got standard error, median, range. Range was max minus min. Remember, we talked about that in the last episode. Nope. Doesn't show the fences. So you can't find the fences there. Then our formulas that you have here, IQR is Q3 minus Q1. Lower fence equals Q1 minus 1.5 times the IQR. And upper fence equals Q3 plus 1.5 IQR. And if you're clever, just calculate this once and it doesn't change for both fences. All right, that's it. Peace. And we will end the recording. Take care, everybody.